Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and in today's video we're going to do a little surface grinder work, some lathe work, and some mill work. What we're going to do is take this very rusty pitted piece of what was originally a 2-inch square wagon axle. Now this is the last piece I've got of that wagon axle. I've made tool holders out of it, numerous different things. I can't even remember right now, but it was about a 3.5 foot, maybe 4 foot piece, and this is the last I've got left of it. And what we're going to do, as I say, is we're going to surface grind this down flat and make a block anvil. Now, in the past, you've seen me make some anvils here in the tin barn. This is one that was made from the top of a piece of railroad track iron, surface ground. I use this a lot on the workbench. I've even used the punch out hole down here for removing pins. But it's great just to sit here on the workbench. You got something you need to do a little extra hammering on where the wood workbench it's not sturdy enough. This comes in good. You've also seen me use, and I think I videoed part of the making of it, my railroad track anvil I have outside near the forge. Now this bench anvil, I don't know whether you've been with the channel long enough to hear the story on this one or not, but this is what my grandfather called his anvil. This was on a post under his tractor shoulder, one of his tractor shoulders, and he always called me Big Shot, but he would get on me big time. He said, "Big Shot, don't you move my anvil." And but it was always set on the top of a post, and it was used to drive out pins and the old mowing machine blades, just whatever needed a good solid surface. Again, if you've been with the channel very long, you may remember the story of how this disappeared for quite a few years, probably 10 years or more, and then reappeared one day. But in today's video, we're gonna take this, flatten it out. We're gonna start first surface grinding this worst pitted side. I've gone over to the dirty side of the tin barn and knocked off any ridges on this side, which was actually the best side of all of them. I think this probably set under the wagon as such, and water just ponded on top up here and caused these rest pits. But I've cleaned that out pretty good, or cleaned it up pretty good, so that it actually hinges, or it doesn't hinge on any particular point. So any high spots are gone off of this. So let's turn over to the surface grinder now. I would put this on the mill and mill some of this off to begin with to get it down close to the bottom of these pits. But this is a very hard surface on the top where that rust has formed. So we'll go straight to the surface grinder. It'll take numerous passes. This is probably 125 thousandths, at least an eighth of an inch thick, or eighth of an inch deep. As I said, this started out as 2-inch. If we wind up with 1 3/4 inches, maybe 1 5/8 inches, I'll be happy with that. But what I want is a good square block anvil to use in working with sheet metal. Alright, over here at surface grinder now, I'm going to take this surface that, like I said earlier, was about the best surface of all 4 of them to begin with, and I took the flap desk on a 4.5-inch grinder and flattened that out so that it pretty much hinges, or doesn't have a particular hinging spot. We'll set that in mag the chuck down. Now when you're dealing with a piece that's as rugged as this is, probably the best place to set your wheel is look for the best edge. This is all pitted down here. This edge over here is pitted pretty bad. So let's come to this edge and just gradually move our wheel down. Alright, that's just touching right there. I'm going to roll it out and I'm going to start the wheel moving. Now let's get our side to side motion going. And I'm going to very easily move the workpiece under the wheel, just in case there's a high spot somewhere. And by the way, I dressed the wheel the last time I used the surface grinder, but when we get ready to flip sides here, I'll show you the process as well that I use to dress a wheel. And again, I'm just being very cautious right now of any possible high spots. Okay, we've passed it all now. Now to begin with, I'm just going to do a coarse feed down. Let me pull you up a little bit. This particular surface grinder, the Harried Super 612, mine has two wheels on it. This one is the coarse adjust, and then this one is the fine adjust. One revolution of this is 1/1000th. I'm going to use the coarse adjust now to begin with, and I'm going to come on down about 4/1000ths at a time. And we're going to go ahead and get some coolant running on this. There's no need of a whole bunch of flood, just enough to wash the piece and keep it cooled off. And I'm taking about 100/1000ths per pass on the Z-axis here. All right, I'm going to come down another 4/1000ths. Alright, so here's what's happening so far. As you can see, we're hitting the high spots. We've got right much to go, especially in these two rust pits down here. I'm going to keep doing that 100/1000ths at a time. When we get this to where it's cleaning up all the way across, we'll flip it over. I'll bring you back then. We'll redress the wheel, and then I'll flip it over, do the back side of it over here, and then continue with these two sides. Alright, we've gone down 145/1000ths so far. Excuse me. We got this one little spot right here left. So let's see if we can't take a couple more drop downs on that. And I'm actually going 5/1000ths at the time now. I started out doing 4, but I've got a right new wheel on here, and so it was it could take quite a bit more than the 4/1000ths. All right, we'll go down 5/1000ths now, and I'm only stepping over on the Z-axis 50 thousandths at the time now versus the 100 thousandths I was doing earlier. I started doing that when we started making contact with probably 75, 80% of the surface. Still a tiny little speck right there, which would be perfectly fine for a bench anvil block. But what the heck, let's do it. Let's clean it up. And that got it that time. Alright, that cleaned it up all the way. I'm going to come down 2 thousandths now and just do a couple cleanup passes. Alright, and for this final pass, we're going to go 1 thousandths. If this was a part I was doing for NASA, I would probably do a wheel dress just before this last pass. But I believe it'll be okay for what we're doing here. And now, without adjusting the wheel, I'll just spark it out. Most of what you see on these spark out passes is where just a little piece of grit got left on there, didn't get washed off. Alright, turn our coolant off. Workpiece is nice and cool now. Compared to, this was the second worst finish here, or side. I think that looks a whole lot better. Alright, let's clean the vise off. And I told you I'd show you how I do a wheel dress. Okay, here's a little diamond dresser on this stand, and I'm going to mag that down and pull the diamond up under the wheel. Now, you want it, the wheel is turning, of course, this direction. You want this just a little beyond the bottom of the wheel. So if anything happens, it'll kick it out this way instead of wedging it behind the wheel. Now, on this surface grinder, I added this lock on this axis right here. That'll keep it from accidentally pulling in. So let's come down until we pull the diamond out of the way. Once it is up to RPMs, and I'm just advancing down 1 thousandths at the time now. Alright, it just touched there on about half of the wheel. Okay, you remember I said that this wheel is 1 thousandths at the time. I've got the course feed locked down. I'm going to go 1, 2, 3, 4. Now I'll make a pass. And I'm going to look down at the edge of the wheel, and I see that that's not cleaning up all the way across. So I'm going to go 4 more again. 1, 2, 3, 4. And that is cleaning up all the way across the wheel now. Remember, 4 thousandths is approximately the width of a human hair. So I've got 4 thousandths that is touching all the way across on the wheel. Now I'll go 3 thousandths. 1, 2, 3. Now I'll go 2 thousandths. And you can tell by the sound too, as far as whether or not it's contacting the wheel. 1 thousandths. Another 1/1000th. Then just a cleanup pass. And that has a good clean dress on there now. Alright, so what I'm going to do now is turn this over and do what was the flat side. We've got a good flat surface right here now. So I will turn that over, do that side, and then I'll bring you guys back when I get ready to turn it and do the opposing sides as well. Okay, this opposing side that I said earlier was the best looking side to begin with of the four. Only took 35 thousandths to clean that up. And you can really tell that the first surface we did is clean. It's magged down now, and it's actually holding water in this hole right here, holding coolant. So what I'm going to do is take this up now, clean the chuck back off again, give another dressing, and then we're going to take one of these finished sides and put it up against this fence. I'll probably do this side right here is the worst of these two. I'll do it first, then turn over and get that. Now, I'm not concerned about this being exactly square. That's no concern whatsoever. I do want to be sure that each of the four corners is perpendicular to each other. And when we finish, that the ends be perpendicular. As you can see, this saw cut right here is probably, I don't know, 70 or 80 thousandths at an angle. Alright, I think we're done with the four sides on the surface grinder now. We're going to come back to the surface grinder a little bit later. Our finish up will probably be on the surface grinder. But for now, I think we're going to go over to the mill. And if this piece did not have a hole in it, I wouldn't concern about putting one in there. But since it does, and we're making everything else so nice and smooth and finished, we're going to bore out this hole here to whatever it takes to make it a clean finish. Then we're going to go over to the lathe and use it to rough out the end, face off the ends of these to a rough finish. Then we'll come back to the surface grinder one more time and do our finish grinding on the ends and chamfer these corners. Okay, I'm over at the end mill now, and I think instead of trying to chuck this up in the lathe to face off these ends, I'm just going to go ahead and clean them up with a large end mill right here in the mill. I'm going to clean up both ends and then clean up this hole, that pre-existing hole in the center. Okay, I think we're done at the mill now. We're going to go back to the surface grinder and chamfer these edges right here, and then I think we'll be ready to wrap this video up. Before I do that though, I'm going to go over to the little drill press and put a little chamfer on this hole we've just cleaned out as well. Okay, before we start chamfering these four sides, edges on the four sides and the two ends, I got another little anvil I wanted to show you. At the beginning of the video when I was showing the various bench anvils that I had and the railroad track anvil, I kept thinking in my mind there was another one, and there was this one, of course. This one is round, lots of holes in here for different sizes of pins, punching out pins, hollowed on the inside, and hex for holding in the vise if necessary. Now, if you're fairly new to the channel, you may not have seen this before. This is what I refer to as the Tom Lipton chamfering block. Tom Lipton, Ox Tools, showed this on his channel and made the plans available. But we're going to take a minute and show you how this is set up and how it works. Get the wheel on up here out of the way a little bit. This pocket in the back right here is meant for the wheel to fit into. Now I don't want my table moving anymore. Okay, I don't want my table moving anymore in this direction. So I'm going to use this lock down here again and lock that. Now this block is made of aluminum, but under the bottom down here I have screwed on a steel piece which will mag down. So the chamfering block is stationary at this point. Now I've got this little steel block that I like to use. Periodically I have to clean off the edges, make them square again. But I'm going to set this in there and gradually move the table in until this just touches off. I'll set 0 on my dial down here and then probably advance in about 30 thousandths. I've got the cover up now just so you can see what's going on. Alright, with this in place, I'm going to set my block up here, get it bottomed out, and just very slowly move this in. Alright, that touches right there. So I can put this back out of the way over here. And down here it's probably off camera, but I'm just setting the 0 on the Z-axis dial. And I'm going to come in, I'm going to start with 20 thousandths. And I like to pretty much flood this block to keep the grit washed off of it. I think I can probably close this down now. Alright, I have the table locked down on this axis. I will also lock it down on the Z axis. That is up underneath the table down here. Alright, we're going to take our workpiece and just slowly Alright, that's give us a good chamfer there. I'm going to go in about 10 more thousandths though. Let me release this lock. I want these edges to be 90 degrees, but it'd be fine to have a good chamfer in there to fit in the bottom of a bend. Alright, let's go back to the workbench and we'll do a quick recap. Okay, I think we're finished now transforming that old piece of rusty wagon axle into a what I think is a nice bench block anvil. We've got everything surface ground. Let's see what it actually turned out. Like I say, it started out as a 2-inch piece, 1.607 that way, 1.871 that way. But we got good 90-degree angles on all 4 sides. We've got the ends perpendicular to the sides as well. And as I said earlier in the video, this will likely be used, or its first purpose is going to be on some sheet metal work. And that will likely be my next video, is working with the box brake that I have over there and making some tool trays, or making some material trays. Hope you got a little bit out of this video and enjoyed it. Take care, and I'll see you on the next one.